Okay, now we are here where yes, we are uh, at this point k plus 1, that is y20, this point. Okay, and at this point we will evaluate the objective function. Okay, and we will find the objective function is got minimized. Now yes, uh, in this step, in this pattern pattern direction search, we said that here yes, yk plus 1, that is y20 is obtained xk plus 1, that is x2 plus lambda star s. And I told you to refer the univariate search method in order to find out the lambda star, right? Why? Because yes, or you can say this lambda star you can find by one-dimensional minimization problem, by considering it as a one-dimensional minimization problem that you will get. Okay, if you refer it, you will understand. Now the next step, step 6. Okay, step 6, and we are here. Now in this step, what we will do is we will set k equal to k plus 1. That is, previously it was k equal to 1, right? Now we will set k equal to k plus 1, that is k is equal to 1 plus 1, that is k is equal to 2. Why we are setting k equal to 2 is in the next step we will go for the exploratory search. Exploratory search in x1, that is u1 and u2 directions. In this case, u1 and u2 directions, right? So we have k equal to 2, and from we have the point we have here. Now from here we will repeat the step 3. Step 3, that is exploratory search. This. So what we will do, we will choose the direction parallel to x1, that is u1. Okay, and we will select, we will have this kind of sets, so that we will find out the direction, whether you have to go in this direction or in this direction you have to go, so that we will get. Okay, suppose the direction is this direction, and we got a new point here in the exploratory search. Okay, exploratory search, that means this will be yk, that means y2, I'm saying y21 will be here. And then in the next step, what we will do, yes, we will evaluate the objective function f of x here. Okay, here, and we will apply these conditions. Okay, so that we will get y21 here, yki y21 we will fix here, and in the next step we will choose the x2 direction, the direction parallel to x2, that is u2 direction, and we will go in this manner, in this direction, and also in this direction. Okay, in these two directions we will go, and this is we will get 2 points, and this will be f plus, and this will be f minus, and this is f, and again we will evaluate the objective function at these 3 points, and we will find out which point is minimizing the objective function. Okay, and suppose that is this point, okay, y2, then that will be equal to y22, right, y22, this point. And okay, so we are reached here at this point. Okay, and what we will do, yes, you have to imagine this. You have to extend your imagination to n number of variables, n number of directions. Okay, if we have 3, then we will go in the third direction for the exploratory search. Exploratory search we will go. Okay, and then we will fix it. Then we will end the exploratory search. So the exploratory search we will do in all possible n directions. Okay, in this case we have 2, so we have stopped here, right? And the step 3, then step 4 is also applicable to applicable here, because if it is not minimizing, if the objective function is not minimized, then what we will do is we will reduce the step length delta xi by half, right? Half, and we will again go for the exploratory search, and then we will find out the optimum solution point. Then yes, then we take the new base point as sxk plus 1. In this manner we will get the new base point as xk plus 1, that's equal to x, k is here 2, so x2 plus 1, that's equal to x3 we will get, and this x3 will be equal to ykn, and in this case it will be equal to y, k is 2, so y2 2, right? So this point will be your x3. Okay, and then we will go to the step 5, where in step 5 what we will do is, in step 5 we have the pattern direction search again. That means in this case we will get the pattern direction as x3 minus x2 we will get. Okay, that is xk plus 1 minus uh, minus xk plus 1 minus k plus 1 minus xk. That is what this x3 minus x2. Okay, we will get the new pattern direction, and we will then we will go to the step 6. Yes, finally at the end of step 5 we will get the new optimum solution. Okay, that means we will reach we will reach somewhere. Yes, actually we have this pattern direction like this, and if we apply this pattern direction, then we will get a point here, let us say here. So this will be our x4. Okay, and in this manner the algorithm goes on. It continues like this, and we will evaluate the objective function here, f of x4 we will evaluate, and it will be minimized. Okay, in that manner this process is continued. Okay, and this process is assumed to have converged whenever the step lengths fall below a small quantity epsilon. That is, we will define the convergency of this. Yes, we will do this process, the process. It is not like infinite number of times. We will stop once the step lengths delta xi, where I varies from 1 2 3 etc n, and your lambda. Okay, lambda optimal. Okay, not lambda optimal, actually lambda optimal is not considered here. Delta xi, actually delta xi step length is got reduced, and delta xi will fall less than a quantity is defined as epsilon. Okay, and this epsilon is a very more quantity tending to 0. Okay, so this the convergency of this Hook-Jeeves method is ensured by this condition delta xi less than epsilon. Okay, you can stop when delta xi is less than epsilon. Okay, and epsilon will be given by your examiner in the problem. So that's all about the Hook-Jeeves method. Then yes, your assignment will be this question uh, minimize f of x1 x2, that is two variable two dimensional objective function, that is x1 minus x2 plus 2x1 square plus 2x1 x2 plus x2 square. Yes, and he has given the initial point, that is base point x1 as x1 equal to 0 0, and also he has given delta x1 equal to delta x2, that is step length equal to 0.18 he has given, and epsilon, so epsilon equal to 0.1. Okay, so minimize this function. Okay, this is a there is no constraint, so unconstrained nonlinear programming, nonlinear problem. Okay, to minimize it, and this is and adding to this question by Hook-Jeeves method. Okay, Hook-Jeeves method. So that means you have to apply this Hook-Jeeves method and find out the solve this minimization problem, and you will get the optimum solution. You have to get it. Okay, this is your assignment or a review question, you can say. Okay, so thanks.